Hello and welcome to the second Innovation Conversation powered by the Emera IdeaHUB. I'm your host, Mitch Gregory, and today I'm joined by Arad Gharagozli, the CEO of Galaxia Mission Systems. Arad's working on sending Nova Scotia-made hardware to space. He's also working on inspiring and educating the next generation of students passionate about space. Let's get into it.
Welcome, Arad. Thanks for joining today.
Hey, Mitch. How's it going? Thank you for having me.
Good. I'm excited to chat about space. I'm a huge space nerd, so I'm excited to see what you're up to. First question, what do you do?
So our company, our focus is the design and development computer for small and nano satellites with focus on artificial intelligence and machine learning. Traditionally, space has been one of the most difficult industries to present innovation to it. So a lot of the technologies that exist right now have been around for several years, many years, many decades, in fact. And I'm one of those people who truly believe it's time for the space to actually start catching up with the other industries, such as automotive or energy, and bring some of those state-of-the-art technologies into space. So that's what we do here at Galaxia. We are developing state-of-the-art computers that can run artificial intelligence in space on board small satellites.
Awesome. So you're hardware focused, but also I heard some AI. So you're doing a bit of software as well?
Yeah, we develop the hardware itself. So we develop our own computers. They're ARM-based systems for people who are into electronics. But on top of that, we're developing our own operating system for the satellites. And we are developing a neural network-based system that is an AI software that is used in ocean reconnaissance observation. And we basically present this as an entire package. What we are planning to do is basically scale this up into developing a full stack of a satellite that can be used in a constellation for ocean observation, reconnaissance, and imaging.
Nice. So you mentioned constellation there and scale. What's the scale you're thinking? How big? And I guess you can say in U, right? That's the measurement.
No, but when I'm talking about this scale, I'm actually talking about the number of nodes of the satellite. So each satellite represents a node. And so basically what it translates into, more satellites you have in space, faster you can look at a specific spot. So let's say if you have one satellite at the low Earth orbit, that's about 400 or 500 kilometers above Earth. That takes about 90 minutes to circle the Earth one time. But of course, as you're circling the Earth rotation is in there as well. So you're not going to see the same spot after you go one orbit. So what you do, you start adding more satellites or nodes to start kind of revisiting the same spot on Earth more frequently. Awesome. But of course, as you increase the number of nodes, it increases the cost of the launch of the satellite and operation of the satellite. So there is that sweet spot that we are trying to find. Currently, we are aiming to launch our first constellation of a pilot project with 3 satellites. That would just gives us a lot of viable data to see how our AI system and our AI software is working, as well as our computers. Once we prove that, we're going to scale that to 17 satellite, and that would give us about 30 to 40 minutes revisit time with that number of satellites. Hopefully, if everything went well, then from that on, we can just expand on that and increase the number as we go forward, and we can raise more money.
So you want to build the hardware, and then you actually want to launch it and collect data.
Yeah. So, I mean, part of our model is we are actually providing onboard computers to the commercial and government entities if they're interested. However, what I'm more interested in actually collecting the data. So what we're really focusing on and designing this entire system from bottom to top. And again, the most important part of it is a computer that is capable of running these complex information on board the satellite. And that's where our system is a bit different from some of the state-of-the-art satellites that are currently in orbit. Because what we are trying to do, we're trying to make the intelligent satellites. And as we define them, we call them software-defined satellites. So these are the satellites that are highly capable, highly intelligent as a node. But when they work in a constellation together, they know how to basically work collectively. And that's known as a nanosatellite pipeline. So They can kind of do a handshake in a space. They can know which space they've been visited, and they can ask the other satellite to kind of maybe put more emphasis on a specific location. So yeah, we are basically developing all of that. What I like to see Galaxia within the next 5 years is be able to have our own constellation in space. And again, specifically what we are focusing on is IUUs, which are very close with illegal fishing, illegal trafficking within the Maritimes.
Oh, cool.
As you know, Canada has a very vast coastlines. It's very difficult to monitor it at all times, and it's a huge vulnerability point for us. So what we are trying to achieve is be able to give visibility of Canadian coastline within 300 miles basically every 30 minutes. So we should be able to detect any vessels pretty much is able to do a cross-Atlantic sail. We should be able to pick it up and
You think it's big enough? Yeah. My little 16-foot, you wouldn't be able to see that, but big vessels you'd be able to see. Yeah. Wow, that's cool. But what would the size of, so you want to build a satellite, right? What would the size of your satellite, like how small have nano satellites gotten now? What would you realistically want to launch?
Yeah, so I mean, the nano satellites have evolved. Our technologies have evolved so much that you can probably build a satellite, I'm pretty sure, smaller than your phone, and it should still operate in space.
Wow.
But when it comes to specific missions, there are some limitations with that. So in our case, we are talking about very high resolution, they call them multispectral. So that means you have different sensors that sense different things. These just stack up, like if you have a camera and then when the optics and the physics of that come in, then you have like a very minimum, for example, 20 centimeter lens that gets in there. So there are some restrictions that we have to follow. What I'm hoping to do is be able to pull this off using a 3U. That's a 30 centimeter by 10 by 10. If not, we might scale that into a 6U. That's like a 3U satellite stacked next to each other. So that's basically 30 centimeter by 20 by 10. The issue is as you increase this number of U's, obviously you have more flexibilities. You can gain more power because you have more surface area. But as you increase the number, then it increases the cost of manufacturing, increases the cost of launch. So what we are aiming for is how are we able to achieve this high frequency visit, high frequency, they call them ISR, intelligence, surveillance, and reconnaissance, with as little money as we can basically spend on it. So that's again, that sweet spot we are trying to hit.
Cool. With all the new launch providers coming up or in the pipeline, where would you target? What would you look at to launch from or with?
Yeah, so there are a lot of launch providers that are coming in, and that's actually one of the reasons that companies like us have the luxury of even being able to dream doing stuff like this, because even like 10, 15 years ago, it was so expensive that pretty much like either you have to be a government agency to do it. But what really dictates our launch is what is called the inclination of the orbit. So that's basically how far you are from the from the point of the Earth. And what we need to do is a sun-synchronous launch, which there are a couple different companies that do that, but we don't know that yet. I mean, we're not as far into the project. Certainly there is new innovations happening. Like, for example, the Virgin Galactic, they are doing a airplane-based launch using a 747. That's very beautiful. But yeah, there are lots of different new companies coming in, really innovative ways of doing it. We are about 2 years away from doing our first pilot constellation of 3 satellites. So once we get there, I'm sure within 2 years, a lot will change. So I'm excited to see that.
Awesome. You mentioned where you're positioning yourself and some of the issues that you're seeing, there being a need for data in the ocean and there being issues with having to network satellites and that enables you to collect more data. What big problems would you see in your industry right now?
So when you say the industry, are you talking about space or are you talking about ocean?
I guess it's tough. You're multi-industry there.
Yeah, we are trying to kind of like, we're sitting at that intermediate point, and I'm not going to lie, there are not a lot of companies doing what we are trying to do. There are a lot of companies, they're known as the downstream data. So we have a lot of, fantastic, fully sophisticated satellites like the RadarSat constellations that, we spend like hundreds of millions of dollars on them. So they send the data down, but then there are a lot of companies that actually just sift through that data and actually try to, understand what happens on the surface of the ocean or even beneath it. And on the other hand, we have a lot of companies that are just like solely focused on either space or ocean. But what we are trying to do, we are this like new, I would like to think about it, this new genre of companies that we're focusing on ocean from space, but we're developing everything from ground up, because there are two ways, I guess, you can approach solving a problem. One is you either kind of look around and see what's available, and you try to, find solutions through that. So I think those are the downstream companies that are looking through what's available. But I think what we are missing specifically when it comes to ocean is, again, the frequency of visits. So I'm going to go back to the RadarSat constellation. The RadarSat constellation are 3 satellites. So when they're kind of going in their constellation, even though they are very high resolution, there is a very high, I believe it's about 6 or 7 hours. I got to double check that. It takes about 6 to 7 hours for one of those satellites to revisit the previous point. So that's a huge gap for anything to happen. So what we need to do is like decrease that gap. And again, that's what we are trying to do. We are hoping, at least with our first demo, we can bring that down to 30 minutes using our satellites. And again, we're not trying to like fill in the gap for like, again, something like RadarSat. We're trying to be complementary to that. So what I would love to see in an ideal world is for our constellation, the Mobius constellation, be able to do those 30-minute kind of checkpoints. And if there was something out of the ordinary, we can kind of relay the data, and RadarSat can, they have a very large kind of a swath of data, and they can capture very detailed information of that area down the road. So we are kind of like filling the gap for them. And I feel like we need more companies, smaller companies, to come in and bring, again, primarily innovation, because space is behind. It's, again, traditionally it used to be a very expensive industry to get into, heavily regulated, still is, for good reasons. But yeah, I think when you see more companies kind of entering that role and kind of thinking outside of the box, we're going to see a lot of more interesting solutions for ocean to come in.
Cool. When you say behind, do you mean it just takes a long time to get new innovations out there? It's slow. It's
yeah. I mean, to just give you an example, when you're launching one of these, again, gonna go back to the RadarSat constellation, because that's our Canadian satellite. So that's a $600 million project. So you're not really gonna risk a lot of innovation on a $600 million project and be like, oh, let's put this like new type of processor, because it could easily go up there and blow up and not work, and there goes your entire mission. And usually it takes a very long time to actually launch these, again, because of the regulations. So again, space, similar to aerospace, you don't see a lot of neat innovations in airplanes, especially passenger airplanes, because it takes a lot of work to get those things approved. So yeah, I feel like in space, it's just because of the cost of the launch and operations fairly high, it's a bit more conservative when it comes to change. And again, I'm fully on board with that. I understand it. But what we are trying to do is reduce the cost of launch, reduce the cost of operation. So instead of having a $600 million satellite, what we are aiming for is about like $6 to $7 million constellation. So now when you reduce that by multiple folds, the cost of your mission, then you can kind of take on more risks down the road, because potentially would bring a higher return of investment for your mission.
Perhaps that's something we're seeing with Starlink, and how they have some satellites that they're just deorbiting after only a few orbits, because they're testing different things on the satellite, paints, and they can move them around, right? But there's 1 in 60 satellites that they're doing that with, right, or something like that.
Yeah. So. And I guess, I like always talking about like SpaceX and Elon. Like one thing about like what in my opinion, what makes like SpaceX or even the Starlink companies successful is because Elon is using his private money on it. You know, like he can take as much risk as he wants. Whereas when you start talking about any of the telecommunication satellites, any of the reconnaissance or other satellites that we have, they're either paid by the government or they're paid by a publicly funded company.
Mm-hmm.
So you can't really take risks, and you just like kind of go with things that has been working for the past 60 years, and you're like, why would I change this? It's working, which is again fair. So yeah,
that's why we need small companies, startups that are ready to innovate. I like it.
Yeah.
Is it safe to say that you're the only space company in Nova Scotia, or
we're the only space company that are actually manufacturing hardware?
Cool.
Yeah, I'm sure there are other companies that are in the round. Again, specifically within the downstream data, there are a lot of fantastic companies here that doing very interesting stuff, specifically with ocean. And they're getting the data from satellites and stuff, but their sole focus is how do we go through that vast amount of information that those sophisticated satellites are giving us. As far as I know, we are the only company, I would say even in Atlantic Canada, that are actually developing an entire stack of satellites from ground up. And hopefully we'll be operating our own satellites down the road.
So let's dive into the hardware a little bit. What tools do you use to build your satellites, and what are you leveraging to manufacture here in Nova Scotia?
So that's actually a bit tough. So my primary goal, do as much as I can in Nova Scotia, do as much as I can in Canada, and then basically look elsewhere. We are a bit limited when it comes to electronics. We don't, like the type of circuit boards we do, they call them high frequency multi-layer circuit boards. There are not a lot of companies, unfortunately, that do it here. I might be wrong. Hopefully, if anybody's watching this, if they want to point us the right direction. So some of that stuff usually happens outside of Atlantic Canada, primarily out of Ontario, and some of the boards that we do for prototyping might even happen in China. I try to do the machining here as much as I can. We are working with 2 machine shops here. We are also working closely with IdeaHUB, a big hi to Graham over here. He's been very helpful. So some of the machining, again, at this point, we're doing a lot of testing. So we try to do as much as we can here in Nova Scotia. I like to, keep it local as much as we can.
Yeah, it's understandable.
Yeah. Other than that, our staff are full here. Currently, we have six staff. They're all out of our office here. We're out of Spring Garden Road. They work here, and yeah. So pretty much again local, except obviously most of the parts we buy, they all come from US, especially when it comes to circuit boards and stuff.
Yeah. How did the pandemic and how did the opportunity to do virtual work change things with you?
It did not work well for me at all. Even from day one, the thing is, like, I've been working on Galaxia kind of in the back of my mind since 2017. Like, that's not something that came about recently. But I actually started Galaxia officially early 2020, and I think a month or so after I registered, the pandemic hit, and Dad put everything on hold. And I truly believe in the power of teamwork and the power of being present, and sitting in an office and like kind of bouncing ideas. And obviously Dad just took that right out of that system. I try to keep the momentum going, and it is what it is. You kind of do the best you can, but I'm just going to be perfectly honest. I'm just so happy that we are over that, because I don't think, especially when it comes to manufacturing and things like that, I don't think that's something you can really do remotely.
It's hard with simple stuff. And
yeah,
put
for
together,
sure.
Cut metal, right?
Yeah, but since we're back, it's been honestly like the difference has been immense. Like,
you feel you're over the hump. You're on a right path. You're moving now.
We are moving. We are definitely behind in our deadlines, because again, a lot of the things we try to do, and right now a lot of other probably people in our type of field in electronics, there is a massive shortage of electronics components worldwide. like the big ones, like for example, even like PlayStation 5 and all those big brands kind of got delayed because there's a massive shortage. So yeah, we had a lot of testing planned and we are not getting any of our parts. So that just like, yeah, all around it was a disaster for us.
Oh no.
Business wise.
Well, yeah, it's times like this that you just kind of have to hustle through it, right? And try and adapt, but you get past it, right? It
Yeah.
seems like is there any flexibility in your designs? Can you order from different places, or is it's pretty difficult, right? There's only a few manufacturers that do that specific chip that you need, right?
Yeah. One of the things, I mean, obviously, even when it comes to, again, not to get too technical, but something as simple as like a voltage regulator, like that's something like every design, anything around your house you look at has a voltage regulator, and there's a shortage of that.
Wow.
So it's and what I found interesting, and I wish I had kind of adapted that logic before, is a lot of people, they kind of start buying whatever is available and then they start revising their plans. So they're adapting to what's available as opposed to design and then purchase. It won't probably work for us because we have very specific requirements in mind, but things are looking better.
Might be a good something to adapt to, right?
Yeah, down the road, maybe next one. I don't know.
Yeah, cool. I guess let's talk a bit about how you've worked with the IdeaHUB and how Graham or people in the IdeaHUB have helped you on your journey. Yeah, what have you done with the IdeaHUB?
Yeah, I mean specifically with the support that IdeaHUB had, it's been pretty great. And again, when it comes to, for us, it's been a lot with the machine shop as far as like the hands-on support goes. On the other hand, I've been in very close contact with Margaret from day one, and she's been more than supportive. So I guess on two fronts, again, working with Margaret and IdeaHUB to develop those kind of business connections, meeting with the right people. Even like from the time that I was like setting up the company, that's a lot of work, like getting the legal stuff sorted out. So that has been, amazing. And on the other hand, again, on the hands-on stuff, specifically with the machine shop, we have a lot of electronics and electrical people around here. We don't have a mechanical, although I'm basically thinking about we might have to like hire a mechanical engineer at some point. But so yeah, having kind of someone like Graham who can help us with some of that stuff has been just yeah, it has been fantastic.
Yeah, it takes the weight off, right?
Yeah, for sure.
Move quick, right?
Yeah.
Cool.
Yeah, and I guess that was the other thing, because as soon as like the pandemic hit, IdeaHUB shut down too. So
yeah,
that, and again, same, I'm sure with all other companies. What's that?
So you lost that arm, you lost that ability to move quick and build and test, right?
Yeah. I mean, again, on the business support and stuff, again, Margaret was always there, and we always like, she was always a phone call away, but just that, physical access to things, that was just very difficult.
For sure. Yeah, and doing some kind of background, I've kind of been following the Loris program and recently heard about the Atlas camp experience that's been it's starting in the next year. I guess I have a couple questions.
Atlas is starting next in August. That's
this summer.
Yeah.
Cool. So how does Galaxia fit into Dalhousie with its relationship with Atlas, the Space Camp Initiative, and how did that come about?
Yeah. So basically, what I realized was there are a lot of people coming to Dal, and the ones who at least joined the Dalhousie Space Systems Lab. And I just felt like, we do a lot of outreach activities. We do a lot of kind of planning and all that around ocean, which is, again, fantastic. We are right on the ocean. But we never had a program that would support space in that way. we have a lot of programs that cover ROVs and underwater kind of exploration. But for other type of students who are kind of more into space, like myself, I didn't find something like that. So that's when I kind of started talking with Supernova, and we kind of started planning this camp that will bring students in. We just immerse them in actual hands-on, a mini version of it, of course, how to design, integrate, and build a satellite, and hopefully into the operation. As I said, our company does hardware development, so we are actually developing the hardware for this mini project. So, we have developed an electronic power supply for a satellite. We have developed onboard computer for satellite. So we have all these stacks. We have reduced the complexity on some of them, so they're like kind of simplified version, but they actually show what a satellite stack would look like. But my vision was that we can actually bring these students, put them through in a hands-on experience to teach them about pretty much like how do you start from concept all the way to operation and deorbiting, and everything that happens in between. So we have a very interesting program planned. There's going to be a lot of like electronics design. There's going to be CAD design. There's going to be a lot of there's actually like a classroom component to it that goes over every subsystem of a satellite. And most importantly, we have fantastic support from the Canadian Space Agency. We're going to have 6 of their engineers. They're going to join remotely and do 6 different sessions. So there are people who are involved as part of the James Telescope project. There are people who are, in the operation room operating the Canada Arm or operating the RadarSat constellation. So all these people are going to come in and talk to the students. And it's very important to have those role models here and teach them that you can come in, you can go to Dalhousie, do the engineering or science program, and then do this at the end if you want. We opened the application. We got overwhelming amount of support. And right now the program is full. So we have 20 students for this August. Unfortunately, we couldn't open it to the Atlantic Canada because of the restrictions at that time. But next year, what I would love to have, and that's the vision of the program, is that we will bring students from every province of the Atlantic into here. We will pay for their accommodation and everything. They will stay for 2 weeks and they will go through the program.
I think this is amazing. This is like an inspiring, not only story and how it got put together, but also I can just imagine how many students are going to go through this and learn and go, wow, I can have a career in space. And I can have it here in Atlantic Canada, and you can show them the path that they need to go on in order to do that. So, and you have some serious weight there. Like the Canadian Space Agency has people coming to teach. That is serious. It's not just a backyard camp, right? This is a real deal.
Yeah. So, no, this is again. I'm very excited. I should really thank Supernova on that. They've been an immense support on kind of doing the logistics and stuff. So we are kind of focusing on developing the technical content, developing hardware, and all that jazz. But yeah, we have had support from Dalhousie. Scale AI actually is one of our biggest sponsors. The Nova Scotia government is one of our sponsors. So I should really thank all of them. And it's a group effort, but I'm just happy that it's happening. And as you said, I hope that these students will come in and hopefully they will get inspired. And when we were kind of going through because they had to write an LOI, like a letter of interest, almost do a short essay, and some of them were really inspiring. So I'm really happy that they have the opportunity to come in and actually be part of this.
It's a great way to recruit, in a few years when you've got that satellite constellation up there and you're like, man, exactly. I need to build another one. Who do I talk to? And 6 years down the line, some of these students are in engineering and they're looking for jobs, and you would have already given them the basics, so that's really cool. Now I'm actually a student now, and I have a lot of friends that are connected with the Dalhousie Space Systems Lab, the LORIS project. You must have a connection to that. What's that look like for you?
So I founded the Dalhousie Space Systems Lab in 2017.
Well, that would be a good connection.
Yeah, that's my connection. And at the beginning, it was a very small group. It was 3-4 of us. and I started talking with this organization out of BC, satellite design Canadian satellite design competition, and which was amazing because, again, as I said, like the camp, there was no kind of a group or a competition or anything like that, even at Dalhousie, that kind of focused on space. And that was the reason I was like, that's what I'm interested in, and that's what I want to do. So I kind of put that together. And at the time, some of the people who I was going to school with, they were like, came in, and it was at a time, it was like 3-4 of us. We ended up connecting with some faculty. Fast forward, we got a contract with the Canadian Space Agency to build the LoRa satellite. So, and that was a huge help for us. And because at the time, I was like, when I was putting the team together, I was basically thinking I'm going to go start knocking on doors, start raising money so we can build our small satellite. But then I guess we got very lucky that we got a contract from CSA at that time. So yeah, fast forward, I guess 3 years now, we had more than 200 students who went through DSS. Currently, our team is about 63, 64 students right now. It's an interdisciplinary team. We have, we are heavy on mechanical, electrical students, but we have students from arts and science. We have computer science students. And project is going forward. Again, similar to Galaxia, we've been hit very hard with COVID. We lost our space on campus. So, we suddenly had to put a halt on the project, but everybody's just kind of going forward. We actually just had a recently recruitment session. We got some new students. But so far, we are on schedule to have a launch for the first quarter of 2022. So, which is in 8 months.
That's pretty incredible.
Yeah.
And students doing it, right? So you have a bit of a leadership role. Obviously, you have some serious experience with this stuff, so you can kind of put that on to them. And they're the ones that are designing and building stuff, right?
Yeah. So basically, the structure of the team, there are 7 subsystems of the satellite. Each subsystem has a team lead, and each team lead is basically, it has to be a student, in fact. And each team lead has their own team. What I like to do is kind of encourage people to kind of open up that leadership position so they can bring on someone else from their team. So everybody kind of takes turn. What I really like to focus on at DSS, and we have had this opportunity to work with a lot of local industries, because space is not just space. Space is, as I said, is a highly regulated industry that focuses on top quality work. So that's not just space, that can go into biomedical. We are kind of developing the next generation of engineers who can actually fuel the economy of this province, hopefully. Yeah. And that's the thing. I'm usually in contact with local industries, primarily aerospace defense. But if anybody else is out there, if they're interested, what we are really focusing on is, on top of teaching the technical aspect of it, is actually how to teach them leadership, how to teach them ownership of their work, and some of the professional kind of attributes of an engineer, like how to prepare reports, how do you do presentations, how do you do public speaking. We frequently meet with the Canadian Space Agency. We have to do presentations on our work. I always encourage people to go on and, stand up on the podium and talk. Most people might not like it. I mean, nobody's forced, but I like to encourage, you have to do this for your work. So this is the best place to do it.
To get going. Yeah.
Yeah.
In my work, I found that, you can't really just focus in on the technical. You have to look at it as a process, right? There are so many components of a successful project that engineers have to be good at, right? So I understand exactly where you're coming from, and it's really important to an engineer that's coming through the system and is learning, right? So it's incredible to see that and see it here in the Maritimes because it's building the next generation of big thinkers.
Exactly.
What else do I have here? Yeah, certainly super inspirational.
Glad to hear that.
Yeah,
you should join DSS.
I'd actually love to. I've got my hands a bit full with
Yeah, I'm sure.
some electric vehicle work. I'm working on the Formula SAE team,
Oh,
trying to
nice.
build electric vehicles. But I'm looking at the work that you're doing, going like, this is the kind of thing that we need to replicate and do more of. Because you say, yeah, it's not in. There's program streams for oceans, and there isn't any for space, but nobody is doing it the way you're doing it, and the way you're doing it is integrated, and it's certainly impactful. So I'm looking at like, this is kind of the thing we need to see on different industries as well. So, electric vehicles is kind of what I'm into, but
Yeah.
I can see this being a successful and repeatable kind of process for all different kinds of industries. Um, the integrated learning, right? It's really important.
Yeah, and it's in my opinion, it is very important to again integrate some of those real world challenges of the work. Like engineering is not you're not always going to sit there and like design cool circuits or cool mechanical parts and that would be it. Like there's a lot of boring paperwork to it, but it's important and it's absolutely important to do that stuff. Even for our team, like I probably ask our team to they have to do a quarterly report as what they're doing. On top of that, we do like risk analysis, we do risk matrices. There is a proper process on like how to purchase this stuff. Like we have a purchasing system in place. So I really, my vision is again like kind of run it as an enterprise kind of.
Yeah, it's really it. Yeah, engineering is it's so connected to business. You really have to look at it that way.
Yeah.
Right.
Yeah.
In your lifetime, I got a couple more questions here I kind of want to close out on. And in your lifetime, have you had any memorable experiences or mentors that have given you the experience and the courage to kind of do what you do?
I got a big shout out to Dr. Plocknet, Dr. Kevin Plocknet. So Dr. Plocknet is the PI of the LORIS project with the Canadian Space Agency. And I remember the first time that there is a bit of a story behind that, because when that Canadian Space Agency grant came out, at a time we were a student group, so we submitted this like full-on proposal to the CSA, and I got a call from them, and they're like, "Who are you guys? Like, I don't know any of these names. I don't see any PhDs in your list. Like, what are you doing?" And then we realized that we weren't supposed to submit an application like that. We had to go through like a faculty, I guess. But then apparently Dr. Plocknet and his team already submitted an application, but they didn't have like a student component to it to do the project.
So
we quickly connected. Yeah, exactly. And, I really gotta, again, I always tell him as well, he's been so supportive of me and kind of trusting that I can do the work and kind of let me steer the project to some extent. And he was always kind of sitting on that mentorship role. So it's been amazing to work with him. And yeah, and even to this point, I'm kind of like in close contact with him. I'm currently doing my master's degree actually with him. After that, it's been an absolute pleasure working with him. So he's definitely one of my mentor role models, I would say.
It's great to hear about the connection with a researcher. He taught me it was materials. Second one, and he's very practical, and he showed examples. I'm not going to say half the class, but a lot of the class was take a look at this real world example. This is where that math connects, and that's how I learned, is the connection between the two, right?
Yeah.
So, great professor, and I'm glad to hear about that.
He's amazing. Yeah.
My last one here. What would you say to yourself 10 years ago?
That's a tough question. I want to say, usually when I'm asked that question, I want to say nothing. I did the things I did 10 years ago, and I think that made me who I am right now. I think, I made a lot of mistakes. I started businesses before. I remember one of my first businesses, I started a computer repair shop. It was called PC Pal. It was out of Titus Street on Lacewood. And I burned like 12 grand into that business and shut down in like 6 months. And I learned a lot in that business, and I feel like it's just like that series of things that happened that built you who you are over the years. But one thing I would I'm happy I did, and I will continue doing it, I guess, is I have good connections with people. Like when I have a lot of, I try to surround myself with good people. Okay, I don't want to say successful or people who are well spirited or uh, obviously they have achieved things in their lives, and again, kind of keep them either as mentors or just be in touch with them. They always like bring so much to your life, and if you surround yourself with the people you want to be, you will ultimately kind of, I feel like you form that mentality and you start following them. So it's important to uh, create good connections. You never know who you're going to run into. And that has happened to me, like the people I've worked with in different companies, even, for example, I ended up like, getting a contract from them like 5-6 years down the road in a completely different setting. Uh, yeah, make sure that again you surround yourself with good people and you don't burn bridges. Basically, just be a decent human being with everyone, and that's probably what I would tell myself 10 years ago.
I love it. That's a great message. I got to say, you're an inspiration. And I've had a great conversation with you today. So thanks for your time.
Thank you so much for having me, Mitch. It was really awesome talking with you, and I wish you all the best with your venture as well with IdeaHUB. And yeah, thank you for having me.
I had a blast speaking with Arad. I hope you enjoyed that conversation. It's always fun talking with somebody who's got a passion for what they do and is giving back to their community, making things happen around them. If you have somebody who you want to hear from next, let us know on one of our social media platforms, and we'll try and make that happen. I'm your host, Mitch Gregory. Catch you on the next Innovation Conversation.